Welcome back to All This Math. This is Professor Parker, and make sure you are subscribed to the All This Math YouTube channel. Make sure you like this video, share this video, drop a comment below, let people know what we're doing at All This Math. All right, today's video was brought to you by Asada Shakur. All right, you can tell I'm a huge Asada Shakur fan. Got the T-shirt on. If you watch this channel, you know this poster stay up here. You know what I'm saying? I actually got another picture of it in my house somewhere else. Anybody been in my crib before? They seen that other picture before too. You know what I'm saying? So, and also, the biggest testament to that is my daughter's named after her. So, you know, when I read her autobiography, it changed my life. So that's why that's why she's such an important figure in terms of the work that I do, the work that we do on this channel, and all this math, the programming that we offer to the community, resources, and everything. So I definitely recommend that you familiarize yourself with her work, read her autobiography, do your research, do your Googles, whatever you got to do. All right, today's lesson. We're simplifying an expression. All right, there's a lot going on here. All right, it's a whole lot going on. All right, the first step is to know how to read the problem correctly. You got to read the problem correctly. Okay, so what do we have? We start from the far left, right, and we read to the right. Right, just like in the English language, how we do it. So we start at 5. We do 5 plus 2. Now these are brackets, right? This is a grouping symbol, right? Just like these are parentheses. Brackets, parentheses, brackets, parentheses, right? They tell you that, you know, certain groups of numbers go together. So certain operations will be done together. All right. So this is 5 plus 2 times the quantity of. Times the quantity of. We don't say the word bracket. We don't say that. We say times the quantity of. Now the quantity of what? Whatever is inside the brackets. The quantity of whatever is inside the brackets. Quantity is an amount. The quantity of 20 minus another quantity. The quantity of 2 plus 3 squared. So we got 5 plus 2 times the quantity of 20 minus the quantity of 2 plus 3 squared. Now, a good rule of thumb for these problems, if you got a bunch of grouping symbols, is to work your way inside out. Inside out. So if you think about the order of operations, not PEMDAS, but the order of operations, right? Because PEMDAS doesn't account for every detail in the actual order of operations. And that be having a lot of people confused. A lot of people went to schools where their teachers didn't really know the order of operations, or their teachers didn't really teach the order of operations in its entirety. They taught them PEMDAS because a lot of math teachers be on some type time where they just want to like give you the tricks and give you the shortcuts and everything, and they be leaving out pertinent parts. They leave out very invaluable parts of the process, right? So they give you the PEMDAS, and then you sitting there thinking, because according to PEMDAS, it would make sense that since the M is always before the D, and this is just one issue I have with PEMDAS, the M is always before the D, it would make you think and believe to the point where you're ready to argue and fight with somebody if they say different, that you should always multiply before you divide. That ain't it. That's not the truth, right? Go to any textbook, right, and read the actual order of operations, and it will indicate to you. You multiply or divide as you read from left to right. It depends upon what you see first, right? So those are just some things. So we got to understand the full spectrum of the order of operations, not just PEMDAS. PEMDAS is meant to remind you of the full spectrum of the order of operations. All right, that's what PEMDAS is for. But a lot of people never learn. It's like almost like you teaching somebody a shortcut to something without teaching them the long way. Right? They can't appreciate the shortcut. Plus, the shortcut don't include all the details. All right. So this is a grouping symbol. These parentheses are a grouping symbol. These brackets are a grouping symbol. So what we should do is we should work out in the innermost grouping symbol, which is this one right here. Simplify this expression right here, 2 plus 3 squared. So I like order of operations problems because it develops young people to be responsible adults. And how does it do that? Because it challenges you to make choices about priorities. It challenges you young people to make choices about priorities. So in these parentheses, we got 2 options. We got a plus sign and an exponent. A plus sign and an exponent. So as a person that approaches this problem, I got to make a decision. Should I add first, or should I, what we call exponentiate first? Right? That's mathematical terminology. Exponentiate, right? Basically, it just means use the exponent for real. So should we add or should we exponentiate? Now, according to the order of operations, which is a system, a protocol that we have in place that we accept, we should use the exponent first. We should exponentiate first. All right, so that means we're not about to do 2 plus 3 and then square that. No, that would be incorrect according to the order of operations. So we're going to exponentiate first. We're going to do 3 squared. Now, we all need to know what 3 squared is. 3 squared is an abbreviated form of 3 times 3. 3 squared does not mean 3 times 2. That ain't it. It does not mean 3 times 2. All right? 3 squared does not mean 3 times 2. 3 squared means 3 times 3. What does an exponent tell us? An exponent tells us how many times a base or a factor will be written in a multiplicative statement. All right? So 3 is my base, 2 is my exponent. That means that this is an abbreviation for 3 times 3, because that's 2 3s. Exponent is a 2, I should have 2 3s. The exponent is a 2, I should have 2 3s. If this exponent was a 3, I would have 3 3s. 3 times 3 times 3. The exponent is a 2, that means I should have 2 3s. All right, so look, I'm about to do this. So we're going to have this going to turn into a 9. All right, and then in the parentheses, right, see what I did, right? See what I did, right? See what I did? That turned into a 9 because 3 times 3 is 9. Notice we're not doing 3 times 2. I can't stress that enough. So many students make that mistake every single day. All right, don't be one of them. All right, now 2 plus 9. What's 2 plus 9? Now we only got one choice left inside the parentheses. 2 plus 9 is addition. That's 11. That's going to give us 11. All right, so this is going to become 11. So now I'm going to rewrite the problem. I'm going to bring this 5 down, plus, and then the 2 times the quantity of 20 minus 11. Boom. Look what happened. This quantity right here turned into an 11. Why? Because 3 squared turned into 9, and 2 plus 9 is 11. We're just following steps. We're just going in order. As long as you know the order of operations, you're going to be good. Now, inside the brackets, right? Do 20 minus 11. Now, some people might argue you could just distribute the 2. You could distribute the 2. Let me see. Let me make sure. 18, 20 minus. Yeah, you could. You could distribute that only because this is a plus sign. If this were a multiplication sign or a division sign, you would not be able to distribute that 2. But we could distribute the 2, but I don't really want to distribute the 2. That's an option. And again, that's another reason I like math, because math gives us options. All right, I got the option to distribute the 2 to both of these numbers, or I could just simplify what's inside the brackets. I could do that, which is what I'm about to do. Right? If I was doing this problem another day, another time, I might be in a different mood. You know what I'm saying? Like, it's like you'd be in a different mood for different food at different times. You know? Math gives us that type of power. So, again, 20 minus 11, we should know our subtraction facts. 20 minus 11 is going to give us 9. So I'm going to bring this 5 down, plus the 2 times the 9. Now, I got 2 choices. Now, remember what I told you, right? I like order of operations because it teaches children how to be responsible adults. Because part of being a responsible adult is being able to prioritize when you have a lot of responsibilities. You got a lot of things going on. It helps you with time management. It helps you understand, okay, I got to do this first, I got to do this second, I got to do this third. It helps you to make a plan and strategize. So here I got 2 choices. I got 2 responsibilities. I got to add and I got to multiply, right? But you got to know, okay, what do I got to do first? I'm not doing them at the same time. I got to pick something, right? So order of operations problem. So to all the people that say, you know, what I'm going to use math for? Why do I got to learn this? How's this going to help me in life? This is like a subtle way that maybe your math teacher didn't point out to you, but I'm here to tell you, this is a subtle way that math helps to develop a certain mindset and a certain psychology, which can help you to be a more responsible human being and a critical thinker. So again, because it's very important, because as if you're an adult watching this, I'm sure you can attest to the fact that a lot of times in life, we got a lot of responsibilities. We got a whole lot going on. And sometimes we make mistakes because we prioritize the wrong thing first. And we don't handle business properly, right? Because we might end up doing, the thing that we want to do. No, knowing good and well, that other thing that you don't necessarily want to do, you need to do that first, right? Just like somebody might look at this problem and be like, well, I want to add first. No, bro. You need to multiply first, because that's what the order of operations indicates and dictates to us. You need to multiply these, right? So you need to do the 2 times 9 first, right? Order of operations. All right, multiplication comes before addition. So we're going to do, even though you're going to be tempted, some people watching this going to be so tempted to do the 5 plus 2 because you want to work from left to right. And that's part of it. But working from left to right is subordinate to operations that take precedence over each other. Multiplication takes precedence over addition. So you got to skip the addition, go straight to the multiplication. Again, just like when you got stuff to do. You got your little to-do list. You got to decide what you're going to do first, what you're going to do second, third, fourth, fifth, and so on and so forth. All right, 2 times 9. Make sure you know your multiplication facts. That's going to be 18. 5 plus 18. What's 5 plus 8? Now you only got one thing left. That addition. 5 plus 18. Now 5 plus 8. Now here's another little trick. Not a trick, but commutative property says that when you do addition, the order of the numbers won't impact the sum or the result. I could flip this around and make it 18 plus 5. If 18 plus 5 is easier for you to do, right? Or if you got a young child that, might not know what 5 plus 18 is, and it might be difficult for them to count on their fingers. Say, look, start at 18 and count up. Count up from 18, right? Imagine this fist is 18, and then you count up, you adding 5. So you go 19, 20, 21, 22, 23. That means 18 plus 5 is 23. That's the count up method. That's some of that new math that people don't like, right? And it's not even new for real. It's not even new. It might have a different name from what it had 20 years ago, 30, 40 years ago, right? But the answer is 23. So the final answer to this problem is 23. Look what we did. Break it down. We did 3 squared, we got 9. We did 2 plus the 9, we got 11. Then we did the 20 minus the 11, we got 9 again. Then we did have 5 plus 2 times 9. Do the 2 times 9, we got 18. Then 5 plus 18 is 23. I love it when the plan comes together, right? And when as a student sitting in a classroom, you should always understand every step of a problem. Or if you're reading a textbook, or you're reading an example online, right? Or if you're reading, how a problem is worked out on one of these apps that y'all got on your phones that y'all used to cheat on your homework on, right? One of them drawings, right? You should understand every step. Make sure it makes sense. All right? How'd you get from this step to this step? Where does 11 come from? Right? What happened to the 2 and the 3 squared? Where does 9 come from? What happened to the 20 and the 11? Where does 18 come from? What happened to the 2 and the 9? Right? As a student, you should understand that. As a parent watching this, you should understand that too, so you can help your children with their homework, right? As a teacher, you definitely should understand that, right? That goes without saying, I hope, right? So, yeah. So the final answer is 23. This is how we simplify expressions that look like this. This is how we use the order of operations. Shout out to Asada Shakur. Definitely read her book. Learn about her. And go practice some more of these problems. I'll catch y'all later.